so that it can use some automated procedures and so on. Okay. So that's what I'm trying to do now. I have already started, or it is feeding in. Give me a moment. We will have the system here up and running. So the reference I always gave you, you remember that it is called otex.com/FPP3. That means forecasting principles, forecasting procedures and principles. Okay, version 3. So that's what we did. I'm started the R programming language here. So I loaded these packages as part of FPP3. This is a kind of suggested packages. You're able to see my screen, right? And I'm recording, close recording. This is the screen where you see that I have installed these packages and I am loading it into the library. Okay, reader, which is better than read.csv. It has read_csv, which is better, faster. ggplot2 forecast, FPP2, the earlier version. I also want to include FPP3, of course, TTR dplyr. All these packages will be used while we do time series analysis in general. Okay. So the first thing I mentioned last time is that how do we create time series data? Okay. Because remember, time series is a temporal data set. Its structure is different. Its structure has to have time element, so time series should have, second. You cannot hear me well, Magdish. How about you, Gaushali? Are you able to hear me well? If one person hears well, that means it is going outside of my system well, okay? Gaushali, how is my voice? Or Supriya, how is my voice? Anybody else? Can you give me some input? How is my voice? Is it clear? Usually it is clear.
Yes, sir.
Okay, all right. So let's continue.
Yes, sir.
Thank you very much. So first and foremost, we need to know how to create a time series data into the system. Then only we can visualize, analyze, and predict, forecast. Okay. So that is what I want to make sure today we are very clear about it, and then so that we can do more advanced things as we go along. So part of that is, let me also open that, because I kept all these things open, but today I have to redo all these things. Okay, so first I will teach you what is T-symbol. We kind of address this thing, but we need to review this. As many times as review these things is better. T-symbol is the time series version of Tibble. Tibble is a more modern version of data frame. Remember these things. How many of you haven't heard of data frame? Can you just give me just give me some input? How many of you have not heard data frame? Please, if you haven't heard, only you can say, me or whatever, right? If you haven't heard data frame, so everybody heard of data frame, so what is the purpose of data frame? It brings together the different combinations of variables in one data matrix type structure. Okay. Rows are observation, columns are attributes or variables. Okay, so but that in the time series data, we need a time to be part of that rows of observation. Time to be part of that. So here is an example. The benefit of T-symbol is that it also defines two things. One is time index, and the other one is the keys. Okay, we are going to learn quite a bit of that, details, immediately, okay, in the next 10 minutes. You use the function T-symbol to define a time series object, okay, T-symbol. For example, I define this is until this. If I say only these two, it is really basically the table. Here is the one column data, observation values are another column of data. So I have 15, 16, 17, 18, 19. There are 5 years here, and then 5 observation years. So for every year, there is an observation year. If I use only these two, it is a data frame, table really, right? But then when we define time series data, we need a some kind of a time variable. I have to say some kind of it because there are various kinds of time variables are coming, like weekly, monthly, quarterly, yearly, even daily, and every minute too, right? So, sometimes, and so the table allows you to define which variable is your time variable. Okay, so that's what is called the index. So index is the one that's a keyword. It's called a key variable that defines what is the time variable. So I defined that up to this is really table, but then I also include index to say which variable is time variable. Now it becomes a time series. So let's run this one. Okay, and then just print this one, right? That's what I'm doing here. Are you able to see? Let me make sure it is bigger. Okay, control plus shift plus. Okay. So I will be running chunks of code explaining all these things. Error in table because I did not load these packages. So let me just load all. Okay, it's fine. Let's load all these packages, and then the table will run. Okay, so I installed packages. What happened? Okay. Oh, but now, oh, it's still installing some of them. That's what happens, and then it will say library. Then this will run. Okay, the table will run. So let's do that because I started the R fresh, right? Remember? So I rebooted the system. So that's why it is asking for all those things. That's fine. So let's just hang in there. It's still okay. It just ran. Error, no. Let me see. I think it ran everything. Okay. It should come back with the. Let me do this one more time. It ran. Let me just do the libraries and loans. I can select that, control enter. Okay, it's done all those things. Now it is, let's do this, the simple first time series data. Okay, it ran without any problem. Because it is a RMD file, the outputs are below. Okay, so look at this one. Some key observation I want you to take a look at. This is first of all yearly data. It is a teachable. It is a teachable object. Data frame. It's a yearly data, and it has 5 rows and 2 columns. Okay, 5 rows and that's all it is. It's simple, clear information as to what this object is. The object Y is a teachable object. It is 5 rows and 2 columns. The first column is year, and that is defined as the time element because we define that index as year, right? So this is the year is the index, and it is 1 year data. Every row is 1 year, one year data. That's what it means, 1Y. The observation values of this. This is the time series data, okay? But let's do what if the time is a month, So we have to have a mechanism for that, right? So again, I'm defining, let's say this is the 2019 January data, 2019 February data, 2019 March, 2019 April, 2019 May, and its corresponding observation. This maybe it's a number of units sold in a particular store, right? Just as an example. So this is right now I'm defining as table. Okay, right now I'm defining as a table. How do we start from table and how do we add? How do we handle, for example, monthly data? This is the yearly data, right? So I just defined that one, as a table, which is a data frame. And then I want to make it, so table is a 5 rows and 2 columns. It is just a, character column, right? Month, because that's how I defined here. And now I want to convert that into a table, okay? See, earlier I defined it as a TS, I'm sorry, I want to convert it into a T-symbol, okay? T-symbol, or I think it is better to say T-symbol because time series symbol instead of table, T-symbol. But nonetheless, I might, for convenience, I might change the pronunciation here and there. So hang in there. So I take that data, convert, right now it is a table right now, and I want to convert it to a T-symbol. That means, I have to define something as year month. Use the function year month, and the mutate means basically, create a new variable. Okay, mutate is create a new variable or transform. So take the Z table object, and then you are doing piping this. This means piping the commands. you pipe, you basically convert, add this variable to the table you have, and then you convert that as tsable. Remember, there is a function called as that converts a table into a tsable, which means time series object. And you have to, when you start defining tsable, remember you have to define the index. So this whatever you defined as month here, you are taking it as index here. Okay, so that is how. If you start with the table, which is the standard thing, and we all know how to do table. So if you start with the table, then this is how you convert it into because you need some kind of a time variable. Here I want to use the time month variable, which is slightly a little bit more complicated variation than this one, the previous version. So I create I transform from this month data that whatever I have in the table, I create a variable that is usable by tsable, and then I called whatever the output coming out of this two steps, I convert it into as tsable. Okay, tsable. So now it is again it's becoming a. You can see that initially it is earlier it was table. Now it is I converted into tsable. It is 5 rows and 2 columns, month and observation. But now it has become every row is 1 month. This understanding is very, very important for you. Okay, I'm going to introduce one more thing here, what is called the keys. Just hang in there, okay? But before we go to the keys, as I said, there are annual data, and then there are quarterly data. If it is annual data, use the function start to end. If it is a quarterly data, you have to use the year quarter function. If it is a monthly data, year month. That's what I used. Okay, here I used year month. Okay, year month function. From a variable, I converted that into a year month, basically a month. Okay, or if it's a weekly, I have to use the function year week. If it's a daily, I have to use as date or ymd function. And if it is sub daily, that means as underscore date time, ymd, year month date, hours, minutes, seconds. That's the kind. These are the kinds of functions I have to use to convert transform a very column into a time series index column, and then only it becomes teachable, right? So so up to this, how to. If it can be a CSV file, you can still do the same thing. CSV file, you should have some time-related variable. You convert that into, mutate that into using these functions. Mutate that into indexable variable within teachable, and then you call that as index. Then it becomes a time series. Okay, so far so good, everybody. Now there is another concept I want to tell you. Another concept that is called keys. So why do keys come into play in a time series data, right? So what if you have a time series data that is repeated within the data set? Repeated, you know that it's a yearly 20-year data. Let us say it's a 20-year data, and you are talking about 20-year, let's say annual rainfall, and then you are also talking about 20 years of annual, wheat yield. Wheat harvest. So actually 20 years are repeated with the two sets of 20 years. The first one is the rainfall, annual rainfall, and then annual harvest of wheat. And third could be annual milk production, let's say. Okay, so actually there are three. That every 20 year is repeated, right? That 20 year, if it is every 20 years is repeated by what, right? In this case, product, let's say type. Type could be milk production, wheat production, and then the annual rainfall. These are the three different types. Each type separates 120-year time series data. So that is called key. You all understood what is meant by key? So I'm going to show an example. I already loaded FPP3, teachable data. There is something called, the package. You see this one, teachable data, that is part of teachable, the FPP3 package. So I already have this data set called Olympic running. Okay. So let's run that one and see. So here you see it is already a T-Symbol data. Okay. So you know now how to create a T-Symbol data. That's how it is. This one is created, right? There are 312 rows and 4 columns, and it is a time series data. That's why it is called a T-Symbol. And what is the unit of time? It is, every there are 4 yearly components. That's what it is. Because it should surprise you. Every 4-year component. That's what 4Y means. Every 4-year time index data. That's what this means. Every 4 year. Okay. It is because it's Olympic running data. It's basically the observation is time taken for the type of length, the length of running, right? 100 meters. Let me see what are the different, different meters. There are different, length is, run, right? And also by sex type, whether it's a men's or women's. Okay. So it is every 4 year it is done, and this is the time taken to accomplish by the winner. So in 1896, for 100 meters dash by men took 12 seconds. Okay, that's what it means, 12 seconds. Okay, and 1900, it is the same 100 meters by men took 11 seconds. The point is, I want you to see this one, 4Y. That means every 4th year. Okay, it is repeated. That's what it means here. Okay, it's a time index is every 4 years. And then there are totally 312 observation. There are 4 columns of data in the time series: year, length, sex, and time. So these 2 are keys. That means you will get repetition of this. Length and sex. There are 14 such combinations are there. Okay. That is, there are 7 of them are here. I will show you what those 7 different types of running. And there are 2 genders here, right? Men and women. That's why it is 14 sets of 4-year repetitions of data. That's what this means. Okay, 14 sets of 4-year. So here, let me. So you can see the entire data set like this. Okay, for example, and then you do see some missing values. Okay, it's because because of war, it did not happen. That's what it is. So it's missing data there. And so let us see. What is the frequency of the data here? You already know that every 4 years. That's what this means, right? Every 4 years. And then does it make sense? We have 312 rows. How did it happen? 312 rows. If you divide this, that many in the data set, if you divide 312 by 4, that many 4-year components are there. 4-year rows are there. Okay, 78 4-year rows starting from 1896. Starting from 1896, okay, and then you will see in the end, ending with 2016. Okay, there are 312 rows are there. Every 4-year repeated. So there are 78 types, 78 time series values are there here, and the keys are length and sex. Let's find out how many. I want to show you. I explained to you why there is a NA in year 1916 and 1940 and 1944. What is the observation? So we talked about what is the key here. It is year and gender, right? I'm sorry, length of running and the gender. Those are the variations are giving us as key values. What is the observation? It says the time taken to the gold medal is time taken. Okay, what is the time taken? Is the observation, and I explained to you the key. It is here the type of runnings. Okay, different types of running, and then the gender. How to find how many different combination of key. So I want to explain that to you. How do you see that there are? Do you see that there are 14 different time series data we can pull out if we want? And what does the single series mean? So let's just run. Let's just explore the data. I will answer all these things. I have answered most of them, but this part, how do we find different keys, and then why there are 14 values are there? I will just explain that one. So let's glimpse the data. It is same as structure. It is better. I like it. This is all part of tidyverse. So here the year is, it is giving it as an integer. Length is, these are the different lengths that is run. 6 is men, and then women are coming. Time is time taken. So let's just some unique values here. This is, you can see that there are 100 meters, 200 meters, 400 meters, 800 meters, 1,500 meters, 5,000 meters, and 10,000 meters. These are different running. Everything is captured in one data set. So you got to understand how the data is structured inside. It's very, very important, okay? So that you know which part of the time series, if you want to, you can pull out and do analysis of that one alone, or if you want to differentiate different time series data in one single graph, you can do that too, okay? So let's run this one. It is Olympic running. I take this Olympic running data set, pipe it to find out distinct length and gender combinations. So let's run that one. So here you see 100 meters men, that is one series. 100 meters women, that is another series. So this is a way to make sure you understand how to distinctly think about the various sub-series that are in the time system. Okay, 200 men, 200 women, 400 men, 400 women, 800 men, 800 women, 1,500 men, 1,500 women, 10,000 men and 10,000, 5,000 men and 5,000 women, and 10,000 men, 10,000 women. These are distinct series. If you want, you can pull it up. Okay. So how do we do that? So you can use the, because sometimes you want to think how the data is structured inside and how to pull part of it if you want, okay? If you want to just see graph of only men's data, then you need to pull out. So what we do is we use what is called the deep layer, which I kind of explained last time, but I'm going to explain it more. So is it, so there is another data set I want to use, what is called the PBS, which is the pharmaceutical benefits series. And you can glimpse that one. Let's do that. Two series. I'm going to look at it for you and explain. So here it is. The data sets. What is that? It is the time series data. Data frame T symbol. There are 67,000 observations are there. There are 9 columns are there, and the key combinations are concession type, ATC1, ATC2. These are all chemical combinations, for the medication. Okay, so concession is a different, the pharmaceutical benefits, are given different concession types are here. So we can figure out how many different combinations of keys are there, and if you want to pull out each of these separately, each series, you can do that. Okay, so if the data starts from 1991, it's a monthly data. That's what it says. Okay, year month is monthly data, 1 month. Okay, yeah, 1 m here, and there are nine columns are there, but these 4 of them are, remember, out of that 4 of them are keys. So let me go back. One time series. Okay, one time index is there. One time index, and then the 4, right? Concession type ATC1, ATC2. Let us see all those ATC2. And then, the descriptions are there. ATC1 description, ATC2 descriptions are there. And then script, and then cost. The number of scripts written, number of scripts means each script is, medication delivery, right? Number of scripts written and how much it costs, okay? So you can see this is 4. The description of ATC1, 5. Description of ATC2, 6. Scripts is 7. Cost is 8. And then time index is 9. That is why you get 67,596 rows and 9 columns. That's why it is. Okay, everybody's good. Just I want to find a pulse. Is everybody doing well? You understood why I said that there are these 9 columns are 4 key variables, 2 descriptions, and 2 measurements. Is everybody good? Anybody want me to repeat it? Okay. Okay, good. Bernard said yes. Okay, cool, Bernard. Thanks a lot. All right, so we understand what is the time series data, how it is stored, how to pull parts of the data if you want all those things. Okay, so let's put, how do we pull out, right? So we have to do what is called select and filter. You have to use select and filter from deep layer. So deep layer is part of this. I already loaded deep layer. So it will work. The piping is also coming from there. So I take the pharmaceutical benefits. I want to know the chemical combinations, what is called A10 for diabetics, that's needed, okay? A10. So use filter to filter rows, okay? And use select to filter columns. So what I'm saying is, I'm taking 4 variables from the data set, 4 columns, okay? Remember, 9 of them there, but I take the month, concession type, concession, and the type. So let's see what this I want to see. So type refers to the type of payments, okay? It's a co-payment, and we can find out what are the different unique things are there if you want, right? You know how to do that, okay? So if you want, let's do it here. Unique PBS dollar type, right? Let's see what are those things. So there are 2 different type, okay? Safety net payments and co-payments, okay? These are all the things, different field values you will have in your data set also, okay? So we know there are 2 of them. So we want to take concession, type, and then the type of the payments, okay? And then ATC1 combination, chemical combination is A, and the ATC2 chemical combination is A01, which is referring to diabetes, okay, basically. So I can take that only, that's what I'm doing, month, concession, type, and cost. So remember, cost and scripts are there, but I'm only going to talk cost, not script. Scripts is the number of things written, right? So a number of, prescriptions. So here I take the data set, pipe the output from, with the filter ATC2 equal to A10, that's what diabetes is. And then I pipe that only for the selection of these 4 columns. Okay, select is always for column, filter is for selecting the rows, specific rows. The rows which has the values A10 for the variable ATC2. Whenever ATC2 is A10, we want only those rows. And then for those rows, we want these columns of variable, because there are other variables are also there. So let's just run and see that. And you can see that, it is 800. Now it has come down to 816 rows only. It is very, very important. If you want to do time series analysis, you understand the process I'm explaining. It's very, very important, because this is what tells you that you understood the data structure inside that data set, T-stable data set. If you don't understand this process, then it is going to be tough. We cannot really figure out how to do the analysis, how to visualize the data, and so on. Okay, so there are 816 rows are there. Okay, and 4 columns only we selected, and it's a monthly data. So far we understood everything is good. Okay, and what are the things we selected? Only these things: concession and type. Okay, there are 2 concessions, there are 2 types, so there are only 4 variations of key values. That's what I'm saying. And each key value will be repeated with 1 time series data. Okay, that's what it is. But then because it is 4 are there, if you divide this by 4, then you get the 1 single series, how many numbers are there basically. Okay, so you all understand what it's meant by 1 single time series data out of this complex data, right? Okay, I hope you all understood. Is that a good understanding, everybody? You are with me? Bernard? And who else? Okay, thank you, Bernard. I appreciate that. Brian, Elango, Magadesh, Om Prakash, Supriya. Okay, Gaushal. So let's move on to a little bit more information. So I kind of selected that, I filter it, right? So let's just do that. Run it and then see some output so that you feel comfortable about it. So these are all unique values of ATC2, the combination, chemical combination, out of which we took only A01. Remember, we took only A01. Automatically, A01 will involve only A. So I don't need that, ATC1. Okay. And then so we have that selected. It is a T-stable data now. Okay. Second time. Finally, I have 84 observation because single unique combinations of ATC1 and ATC2. I was just checking something, and here is another thing I'm doing. So once you filter, you can do other things, some called summarize, because there are going to be multiple values here for different so we want to, first of all, we want to take the PBS data, pipe it through this filter process, okay, where we are selecting only A10, which we just talked about, and I want only these four columns, not everything. Not only that, I pipe it further, and where I summarize the cost. I summarize the cost because I have mentioned, it's a time series data. Okay, so it is going to summarize, the whole month. For each month, it is going to summarize because there are months repeated. Okay, so you can see that. Why don't we view this? Okay, sometimes viewing is also another way to do. So view, let's say, it's pipe, but I did not write it into a name. Okay, so I'm going to write it as A10 later on, you will see. Okay, but for now, just view the PBS and then we'll go from there. Okay, just for the fun of it. So it's a monthly data concession. There are two different types, concessional type, and then the type payments are two. ATC1 is A, ATC1 description is here, ATC2 is type is sub chemical combination that is used for diabetes is A10, and then ATC2 description. This each one of these, what does this mean, is given here, description, and then how many scripts are there, how much is the cost. But the thing is, there are 4 observations will be there. It will be repeated, the same combination. Why? Because there are 4, ATC, concession and type. There are 4 of them, right? Totally. Concession 2, type 2, so there will be 4. We want to combine that. Okay, 4 observations that summarize that. That is what this one is about. That is what, 1 second, I have to go back to that. Recommendation engine times this S2. Okay, it went somewhere. I have to bring back here the middle so that I don't lose it. Here comes time series. Wow, okay. Once again, I got too many things going on here. Time series. Okay, this one. So let's move on to that. So the reason why I said there are going to be 4 values that is going to be summarized, because there are 4 per month. Remember, per month there are 4 combinations of concession and types are there. Okay, 4 combinations of concession, 2 concession, 2 types. So there are 4. Those 4 differentiates 4 different values for the same month. So that's why it's summarized will automatically. This is the beauty of the T symbol. It knows which month to bring together. I didn't say month here, by month and all. It simply knows it. I hope you understand that part. Is that clear, everybody? So it simply knows that there are 4 values, so it's going to summarize some of those costs are added and call it as total cost. That's what the summarize function does. So this deep layer is amazing, beautiful. It does complicated, data manipulations for you. Please use that one. So here, that's what we did here. So let's run this one. So here is what you got. So for this month, now there is only 1 value. Okay, there is no the concession types and then the concession variation and type payment, right? It's not there because we summed it, and this is the total cost of all the scripts that were prescribed in 1991 July. Okay, and it is the 204 columns, and there are 204 rows. This T symbol is 204 rows and 2 columns, and it's a monthly data, and that's what one M means. So if you use T symbol, you know what is going on thanks to this data. Remember, okay? And these are all we can go on seeing various subsets of it. Now I want to we can also create new variables. So instead of doing some total, I want to create in terms of millions of dollars. This is instead of writing this single dollar, I want to put this as 3.45 million or 6.2 million, 5.8 million, like that. So that's what this idea is. So I'm doing filter, select, summarize, mutate. Mutate creates, transforms new variable, right? So cost is now redefined from total cost. I'm redefined the new cost. That new cost is how many millions dollars. Total cost divided by this 10 power 6. Okay. So let's run this one. So I'm teaching you now how to use dplyr very effectively in the context of time series data. That is the most important thing here, in the context of time series data. So now I have this one, you can see the 3.5 million, 3.1 million, 3.2 million, like that. So total cost is to cost. And this is also teachable. See, once you have a teachable, any transformations you make and then keep it within that structure, it will be a teachable. So it's a 204 observation, now 3 columns. And let's call that, this time I'm going to rename it, whatever the output comes here, by putting this arrow, that is the important beauty of R. R has this forward arrow, backward arrow, right? Backward arrow means put it in whatever on the left side you have. Forward arrow means put it, name it, whatever you have on the right side. Okay. So basically, whatever I have done so far, I kind of put it under the name A10. Okay. So everybody is good now. The data wrangling part of it. So if you look at the A10, you have month data. This is a teachable. 204 rows are there. It's a month data. There are 3 columns in this teachable: month, total cost, and cost. Okay. So if you want to plot this, we can plot. Okay. So let's go quickly and see whether we want to do whatever we want to do. Now, if you look at now the next data set, I want to read another data set. Now we can do similar exercise here. Then I just want to do one more time. Okay. So I'm reading the data with the reader. Remember, I loaded the reader, from this book, prison population data, which is a CSV. So from CSV, we are going to create a teachable. You remember, I told you you can do similar things, creating teachable from the from any data set, table data set you can create. And this time I'm not starting from table, but I'm starting from CSV. Okay, so that's what I'm doing here. And as soon as I read that, I'm going to take all these things and post it again under the name prison. Okay, or I can call this prison one to differentiate from that. But I don't want to waste my object space, so I just rename it. Whatever I read, same file name is given for the output of this data, wrangled data. The wrangled data, it's happening here, is posted into the same name. Look at this one. So what do? I read the data first, CSV data. That's clear. Everybody knows that, right? Everybody knows that. Now I take that data. Okay. Now I'm piping all these things. Whatever the output I create, I put it I put it left arrow. That means post it under the name prison. That's what I'm doing here. So I take the data, I transform here quarter. It just comes as CSV data. It doesn't know time index, all those things. It is not a teachable. It is going to be a table initially. So I define year quarter. You remember that I told you year quarter. It's not a date, but it's called date, but it's not. We can take a look at that moment. One moment. I'm going to run that one alone. Okay, I ran that one alone, and what do I have there? So here is what I have. So I read from the CSV file, and it has date, okay, and it has state, it has gender, it has legal status, indigenous name. What is the indigenous? The group is from the particular state, and then the indigenous population segment, and then the number of people. Okay, so you can also do structure, right? Or glimpse. Let's see, glimpse. Let's see. Okay, glimpse prison. Glimpse, I can't use it now. Okay, glimpse. Okay, so this is what date means. Okay, it gives you every year, month, date. That's what date is, right? But we want to convert that into, what is that we want to convert? We want to convert that into, here it is, year quarter. We want to summarize it into a quarter level later on. Okay, so we want to take that date and convert it into a quarter. So it has to say year and quarter 1, year quarter 2, year quarter 3. Okay, that's what, that is how we want to define it for each of the rows. And then eventually we will group it, okay? And then select minus date. That means you keep all the variables except date. See, I converted the date into quarter, okay, called it as quarter, okay? And then there will be multiple rows for that quarter data. Remember that, okay? Because it's the original data is in date. And then whatever the output comes, I will remove date. That's what it says. That's all. Select minus date. If I put no minus, then it will select only date. But if I put minus date, it will select all other than date. And then whatever the output that comes, I want to convert it into a teasable object. The moment I say teasable, I need to know index. I need to know keys. Okay. You don't need keys if there is, there are no keys. You don't need keys, but you should at least have index, okay? Because it is a time series data. That's what teasable is. So key is equal to, these are all the key values differentiation. Key value differentiations are state, gender, legal, indigenous. So for every one of the state, for every one of the legal status, every one of the indigenous group, every one of the gender, I will have, the count, right? Number of prisoners. That's what it means. Okay. Is everybody good on this one? See, this is starting from CSV data. So I have given you an avenue, a method, approach on how to create time series data. So far, that's what I have been, hammering in this conversation today, right? So let's run this one. Okay. Because I already ran the other brand, I don't have to run this one, so just run this one. I ran that. The outputs glimpse prism. Now I can use the glimpse. Okay. So that's what it is. State is, these are different states, and you know how to find out the unique states, unique values of gender, all those things. If you know how to find out, you can use two functions. One is unique, the other one is distinct. Okay. So there are 3072 rows are there. When I just did the glimpse, I see this one. There are 6 columns are there. The keys are this. Everything is there. Okay. Glimpse does all the explanation of your teasable object. Okay. So now I can just take a look at that if I want. Just few values. I don't want this. Well, let's run it here. So it says, yeah, it is a teasable object. It is a quarterly data because I converted it into quarter, right? Year, quarter, right? Remember that? That's why it is. So use the date column to convert. That's what the mutate means. Convert or transform into quarter. Column name is called quarter. Okay. And so we want to glimpse. That's what we are doing here. And we are actually looking at the data values rows. So state is ACT. It's in Australia. Female gender, remanded, legal status is remanded. Indigenous group name is ATSI. Number of counts are 0. Okay, it so happens. But then, no, this is the second row, right? This is the second row. For the original data, second row for the original data, present data, right? But in a summarized form, it will be a different one. Okay. Summarized form is we didn't come to summarize yet. Okay. So there are more variables here. How do you know more variables? Just the arrow. The quarter is 2005 Q1. Count is 0. These are the variables 4, 5, 6. Okay, that's why 6 columns are there. 6 variable. It's quarterly. The time index is quarterly. That's all it says. Okay. It is kind of not transformed into quarterly. 3,700 rows are there. So what do we do now? I don't want. I just want to. I'm curious to know what are the different possible combinations of key values are. So I take the present data, pipe it through this process, and output it. Let's see what it is. So it says these are all the different key combination values: ACT, gender, ... So it comes out with 64 different possibilities out there. That's what I mean. These together, there are 64 different possible combination of keys are there. That means for each combination of key value, there is a quarter value. That's what you remember that. For each combination, I have a quarter value. Okay, so how are we doing in terms of time? Oh my goodness, we are coming to an end right now. So right now, let us say, we have done all these things. How about, seeing some visualization? Okay, there are a few visualization. Autoplot automatically will, take the object, and if you specify, you specify the data set name, you specify the variable that you want to plot, it will beautifully give you the time series plot. You don't have to worry about it. It knows what the time index is. It knows what the other details are needed for time series, and it will plot. So you remember A10 is the particular PBS data, that is the pharmaceutical benefit data, drug information data, consumption data, medication consumption data. So it is going to do this, as a plot here. And you see this one. And the interesting thing here is that this is the monthly data. It clearly specifies that it's a monthly data. You remember this one? It says monthly data, and this is in millions of dollars. And the Australian anti-diabetic drug sales. And then interesting thing is it is beautifully having the same cycles, right? Not cycle seasons here. So you can see that it goes down, a particular month it goes up, particular month it goes up, particular month it goes up. I think around December, around December, December, January, it peaks up. December, January, December, January, December, January, December, January, December, January, 1999 and 2000 January, 1999 December and 2000 January. In the same way, this is kind of very beautiful seasonality is here. Okay, so we are going to, so we need to understand what is meant by trend, seasonality, and cycle. Okay, and the trend here is that it is going up like this, and the trend is not only going up, it is increasing incrementally, more and more trend, right? So it is non-linear trend. Okay, it is going not straight forward. Now it is going up. So the what is that called? The first derivative here is positive. First derivative here is positive. All these things, first derivative here is positive. That's it. Maybe it looks like in the short time period, first derivative is very close to zero here, right? But if first derivative is positive, that means it's increasing. Okay, increasing trend. First derivative of a line, right? Here it is not a line. It's the. Wish I can draw that, but I can't do it. I can do one thing. I can do copy image and put it here, and let me put it at the bottom. I can paste it, and then now I can put it trend there. Okay. So let's draw this. So let's just see what the trend is going to be looking like. Okay. Visually, I can say this is what the trend is, right? Let's kind of space here. I want to redraw this again. Insert. So let's do this. So that is the trend. Okay, so let me make it bigger so that you can see that easier. Okay, that is the trend, and the trend is not a line. I just want to impress with you on that one. I want to impress you with this kind of information that it is the trend is not just a line. It is a non-linear line. It is increasing as time increases. Trend is increasing, and there is seasonality is there. There is trend. There is seasonality. Is there a cycle there? What is the difference between cycle and seasonality? Seasonality is tightly connected to time index. So you can say exactly November, December, January, it is happening peaks. That is, and the lows are happening around the summertime, maybe. Okay, it's happening around not summertime. So I think around May, February, March, around March time, the low happens. Okay, maybe this is the high, right? So yeah. So I would say, yes, February, March, it is happening, low is happening, okay? And then it picks up, goes up, December, and then comes down. February, goes up, December, comes down. So there is some kind of a shift has happened here. I don't know what it is, but you can see that here, it's coming out. We may not know fully well right now because the indexes are not, I wish, every point is indexed here properly, right? So, I can say read it off very easily, but I'm not able to read right now. So we have to do a little bit more in terms of how to plot the timeline here and so on. But autoplot does most of your work, and it is a quick and easy way to get your plots. But I also talked about seasonality, cyclical. What is cyclical here? If a cycle is different from seasonal, seasonality is time bound. It is happening. Ups and downs are happening by time. But seasonality is, few seasons combined together, there is an up and down because of the overall things that are happening in the society. It could be economic, it could be social, it could be demographic. Those are considered cyclical. Okay, so I hope you understand the difference between cyclical and seasonality. So we talked about cyclical, seasonality, trend, and then there is a noise. So what is meant by noise? Noise means that it doesn't have a pattern. So I'm going to go at the bottom just to give you what is meant by noise. So here's so I'm going to do I'm going to simulate some data okay, and show you this one. Is there a trend there? No. Is there a cycle? Trend? No. Trend means it is just flat. Okay. So if I do the same thing here, it is just flat here. If you look at it. So let's do this one. So what I'm saying here is insert. Let's draw this line. It's pretty much. Look at this one. It's pretty much like this, isn't it? Flat, right? So that is called, the observation around a flat line is called white noise. Basically, random error. Okay, it's also called white noise or random error. So there are 4 components we will be referring to: seasonality, trend, cycles, and random error, randomness. Okay. Also called white noise. White noise, seasonality, cycles, and trend. We will be using these 4 things. So if we pull out those 4 things, it means we know how to analyze it. That is what I want to do in the next class. In the next class, I will be talking about how do we identify additional components. In addition to trend, seasonality, cycles, and randomness, we also want to identify what is called, we want to use a tool called autocorrelation function, partial autocorrelation function, to find out, whether it's, see, this is easy to understand that, the cycle, the seasonality is there. It's pretty easy, isn't it? Seasonality is there. And there is also, we have to use what is called log transformation, because it is, it is increasing. This, cycle sizes are the ups and downs are increasing as time goes. Okay. So we have to address using some mathematics and computations, understand how I can estimate the trend here. This line I should estimate, right? How do we estimate the trend? How do we estimate the seasons? How do we estimate the cycles? If the cycles are there, as far as I know, there is no cycle here, okay, visually. But we have to do this mathematically. In order to do that, we have 2 important definitions, important components. That is called autocorrelation function. The other one is called partial autocorrelation function. You will use that in the next class and pull out these, estimates of trend, seasons, and cycles. And that means we have done a good job. That way, you can explain your model and predict your forecast, because your forecasts are some of those components. It has a trend component, seasonality component, randomness component, and cycles component. Okay, when you sum those components, you pull out and then add those things and put back into the forecasting formula, you have solved your problem. That's what we are going to do in the next class. Any questions, please? I know we are kind of a little bit delayed. My apologies about that. I don't know. So once in a while it happens, but I think I know how to handle this next time. I have to do this. Make sure early morning. I got up at 3 o'clock today, and then I kind of prepared certain things. Make sure that these are all running. The codes were running and so on. But then the GoToMeeting, I didn't check it out. I should have. I will be from now on. I will just make sure the GoToMeeting is running a couple of hours before, so that I don't face this kind of problem. So sorry about that, guys. I really enjoyed teaching you this. I hope you enjoyed learning this. Any questions? Any questions? This is your time. Please ask me a question. It could be any other question also. Don't worry about it. Not only about time series and forecasting. If you want any questions about data science, any questions about where the technology is trending. By the way, we are hiring many positions in Chennai office in India. Those who are joining in Chennai are interested, please spread the word. Fresh graduates that we are fine. We train them enough that they become really top-notch data scientists and they get placed very well. So if you know anybody in Chennai, ask them to reach out to us. Many positions are all available. The basic qualification is about web programming. You don't need to know data science. As long as you have fascination for programming, as long as you want to do that programming for automation, working with web, working with the apps, working with mobile, you are good for us. Okay, so just a quick note about many positions available in Chennai. Look forward to seeing you, some of you there, or forward this, this request. It's available. The request, I put it in the LinkedIn. We put it in the in our group. We have a community. We put it there. But LinkedIn is the one. LinkedIn and also Twitter. I posted. Anyway, so any questions you have, please right now. This is the best time. Otherwise, I look forward to seeing you next week. We will be fine next week. Okay, I told you how I will handle it. I'll be on time next week. Thanks a lot, everybody. Have a great rest of the week. Bye-bye. Thank you. Thank you.
Thank you, sir. Thank you, everyone.
Thank you, Supriya. Thanks. Welcome, Brian. Thank you, Rango, for sticking in. Okay. Thank you, Francis, joining. Thanks, Gaushali. Thanks, Om Prakash. And thanks, Magadesh. Bye-bye, everybody. Thank you, Gaushali.